room is freezing cold. I'm aware of that. This is a very strange room temperature wise. In the winter, it gets super hot in here, but on a day like this where it's sort of cold, this isn't on very high, is it? Um, but it's before the cold part of the year, it's freezing because they've just piped the air from outside in. So rude. Well, it's to keep us healthy. Even before COVID, it's because it's a chemistry lab, but until they mix it with heat, and we don't want them to turn the heat on, I promise, because it takes 2 days to get warm, and then it'll be 90. So we'll just have to suffer today, and tomorrow will be all right. All right, plan today, section 1.6, and then we're going to start a lab that we'll finish tomorrow. I made a little video. I don't know, hopefully that'll help speed up the instruction that hopefully you watched last night. And then there was a video about percent error that hopefully you watched over the weekend, just to try and catch us up, because we're going to be way behind by next week. But I mean, we have time. So section 1.6, if you went over that, it may have stressed you out quite a bit. And we'll talk about it, but it's not that important yet. We will do a lot of those things. And hopefully get better. Is that louder to you now? Usually I hear myself over the speaker, but I can't hear myself at all. Hello? All right, we'll try that. Okay, so section 1.6 talks a lot about what we call dimensional analysis. And that was too loud now. Okay. You like that? I can make one for you. All right. It's just a free online like maker. So I'll look like a hero and I'll have spent 10 seconds to do it. All right. So we'll learn about this dimensional analysis, and we will use it all year long, but not really how this chapter puts it. All right, so these are the goals: to explain dimensional analysis, and that's called factor labeling, but I call it the picket fence approach to math calculations, and then use it to carry out unit conversions for a given property and computations involving two or more properties. So that sounds really confusing. It's not that bad. All right, so a quantity of interest may not be easy or even possible to measure directly, but instead must be calculated from other directly measured properties and appropriate mathematical relationships. The mathematical approach we will be using is known as dimensional analysis. Dimensional analysis is based on the premise that the units of quantities must be subjected to the same mathematical operations as their associated numbers. All right, that's a lot of words. When the 2002 Olympics came, it was called Utah on the Fly. It was a blog that I would read that people, or it was called a forum. That's what they were called back in the day. And it was about fly fishing. And there was a lot of fly fishers upset because it didn't snow very much that winter, and they needed snow. So they were filling up dump trucks full of snow in the Strawberry River Basin and shipping it to Park City and dumping it. And the fly fishers were just fired up. They're like, we are in a drought. You cannot remove water from one river basin and put it in another. And this is a really nerdy story, but it just goes to this. So I read that and I thought, this is a pretty ridiculous argument. The actual amount of water in a truckload of snow is super small. So I made a comment and I did the math, and no one cared, but it was kind of fun for me. I figured out how many cubic feet per minute of water they were removing from the river per dump truck load. And it was like 0.002. Like, it was not going to affect the flow of the river unless they did millions and millions of dump truck loads of snow, because there really isn't that much water in snow. Now, in order to do that kind of math, I had to know the dimensions of the dump truck. I had to know the water content of the snow. I had to know the flow rate of the Strawberry River. And I just had to do one big, long dimensional analysis problem to figure that out. Then when I was in chemistry, I had the first unit. There's always questions on this. I had to calculate the number of school buses that it would take to circulate or go around the solar system. And so that's just really stupid, but you had to know some factors and line them up in the right way to get the correct answer. So it's a mathematical way to solve problems that can't be directly one-to-one ratio. There's not a ratio out there for dump trucks per cubic feet of water in a river. So we have to convert to other things. Now, some common ones that we use in this world are like centimeters and inches. And so like we don't really use this in chemistry for length very often, but we could use this conversion factor or the dimensions to solve a problem. So if I knew I'm 5'11", so let's see, how many inches is that? That's 71 inches, right? So if I want to know how tall I am in centimeters, I do what I call a picket fence. I take my height in inches. I want to solve for centimeters. And then I arrange this in the way that inches cancels out and centimeters is the only thing that's left. So I find the thing in front of inches 1, in front of centimeters is 2.54, and then I multiply across the top. The unit I don't want cancels out. The unit I do want stays. That's literally all we're going to do. Now, if I wanted to know how tall I was in millimeters, we could do it one more step. So I would follow the same process. I would take the thing that I know, and that's that I'm 71 inches. Oops, that's 1 first. All right, and then I would use my conversion factor where inches was on the bottom, once again, 1 inch, because these units have to cancel out. But the conversion factor, the inch is tied to 2.54 centimeters. But I don't want centimeters, I want millimeters, right? So I need a conversion where centimeters is on the bottom and millimeters is on the top. And for every 1 centimeter, I have 10 millimeters. I need to get rid of this, that's confusing right there. And so then I would take 71 and multiply it by 2.54 and multiply that by 10, and I'd have my answer. Go ahead. Yeah, for sure. You can take all sorts of steps. If I was going to do this, I probably would have done that exact thing or find the answer and just move the decimal one place. Like I would not have done this. It's just an example of how to do it. Now, when you see it in a textbook, you'll see it written different. It would be 71, and then you'd have 2.54 over 1, and then you'd have 10 over 1. And it would look like that. There'd probably be a multiply sign here and here. That's fine. I like to put it just in this, which I call the picket fence, just to keep it lined up and less parentheses. So now, if there's a number on the bottom, you multiply all the top, you multiply all the bottom, and then divide the top by the bottom. If you have a calculator that has parentheses, just make sure that you put this in parentheses. Or for sure, you could do that at 6 in your head and just divide. But do not take 71 times 2.54, divide it by 2, multiply 10, divide by 3. It gets complicated and you'll get wrong. So be careful on the math there. So that is the basics behind dimensional analysis. What we use it for in chemistry is to convert from grams of some substance, so like 50 grams of aluminum, to grams of like aluminum oxide. And we'll learn how to do this later. Don't worry that you are like, I don't know what he's doing. But if I have 50 grams, I put what I know. I put the unit I want to solve for. And then I need a equation, a reaction. So aluminum plus oxygen goes to Al2O3. Then I'd have to balance this. And we'll teach you how to do that soon also. And then I'm off to the races. I need to use my periodic table to find what the mass of aluminum is on the periodic table. It's 27 grams. And once again, this is just an example. You'll learn how to do this, but don't panic if you're like, I don't know what he's doing right now. There's 27 grams of aluminum. I got that straight from the periodic table. It's 26.9815 something, but I rounded. And anytime I do that, that's per 1 mole of it. You may remember from earlier. And then, whoops, that's 1 mole of aluminum. I want grams, so I can take mole of Al here, and that's a 4. And I want Al2O3, so I have 2 mole Al2O3. Down here, I need to get rid of mole. For every 1 mole Al2O3, I have 27, 54, 48, 102 grams of Al2O3. Then I do math. I take 50, I'm going to reduce this to 1/2. 50 times 102 and divide it by 54. And this is what we will do over and over and over and over and over. And once we walk it through, it comes pretty easy. But it's dimensional analysis. It's using things that we know or can find in ratios to go from one thing that's not comparable to another thing that's not comparable. But if we made them the same in the middle, they are comparable. All right, so that is basically it. We're not going to do any of these long, complicated ones. So I'm going to go through here. We'll get way into that math again in Unit 3 and Unit 4, like way into it. All right, temperature, the book talked about Fahrenheit and Celsius, and Kelvin. We care about Kelvin and Celsius. So we use Kelvin a lot. You don't have to write down everything here. You need to know that water freezes at 273. Water boils at 373. All right, 100 Celsius covers the same temperature interval as 100 K. So the change in 1 Celsius is equal to the change in 1 Kelvin. I think we went over that already. The difference between them is the same. 0 Kelvin corresponds to the lowest temperature that can theoretically be achieved. And that's called absolute 0. And it's just barely colder than this room right now. No laugh. Nothing, huh? Last year I was funny. When I ran into some kids and they asked if I'd given out the book yet, and I said I was going online. They said they would drop this class if I didn't give them an actual book. Who's frustrated they don't have a physical, tangible book? You can be honest. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So who's excited they don't have a physical book to carry around? Just 2. And then there's a lot of indifferent human beings. All right. If you want a book that you can carry around that doesn't directly correlate with this, you can have any of those books you want. Like not right now, but we can get you a book. All right. This is absolutely imperative. You don't need to, we don't really worry about the 0.15. That's not necessary. But anytime you convert a Celsius to a Kelvin, which you will do a lot of, you need to know it is just Celsius plus 273. Oh, the water's boiling. I don't want it that hot. All right. So here we go. All right. The way we're not meeting every day is killing me. It might be bugging you too. I don't know. But don't get me wrong. I love getting done at work at 11:30. I'm fine with that. But I wish I could see you guys every day. So here are some things you should do before Friday. You should read chapter 2 and fill in the chapter 2 reading guide at the bottom of chapter 2 module on Canvas. Okay, I'll come back to this page, but I'll just show you what I'm talking about. I published it this morning. It's not exactly 100% how I want it, but it's good enough. I swear I had it open right there. So if you go to chapter 2, it's just right here, this chapter 2 reading guide. If you already read chapter 2, I don't think it will take you very long. It's not really opening, but it's not super long. This is going to be for points. All right, so it's right there. And then the next thing, I'll come back to that page in a second, but it's going to say study these because I'm going to give you a quiz. So study for, this should be the atom or the elements quiz, not the polyatomics. Sorry. Okay, so study the elements. I'll give it to you Friday. I will show you exactly what it looks like. It's pretty quick if you know them. Oh, maybe they're in Goddard's room. Oh, there we go. So you'll literally just get a paper with the 50 elements in random orders. You have to be able to go both ways. So 1 says beryllium, and you would say Be. 2 says O, so you would say oxygen, and so forth and so on. It's all 50 elements. Now, it says you have 2 chances to pass the quiz, one Friday and one next Tuesday. Passing is 50 out of 50. Sound good? No pressure. Now, what are the consequences if you fail? You don't get 50 points out of 50 points. If you get a perfect score, I give you bonus points. If you don't, I give you what you got out of 50. Now, the reason you need to know these is by chapter 3, well, even chapter 2, we'll start writing formulas of compounds. And if I say lead, oh, I think I deleted that. Oh, I don't even know what I did now. Whatever. If I say lead for oxide, and you don't even know that lead is Pb, then you're in a world of hurt. Because you're going to have to write out a whole equation in formula from a sentence. Okay, so you absolutely need to know these things. So lead, PbO2, in case you care. You need to know the elements 100%. Now, if you're a slow memorizer and you want that chance for extra credit, anytime you want to come in after Tuesday and prove to me you know all 50, I'll give you the bonus. Does that make any sense? Okay, so please get on chapter 2 and then study those elements. I don't know, has anyone already studied them and knows them? It takes under an hour, really. Most of them are common sense. There are weird ones, like lead, Pb, it means plumbum, and it's Latin. So there are some that don't make sense, but they do if you know their Latin name. Like iron is ferrium, like a Ferris wheel. So go ahead. Manganese, and it is pretty close. But after years of doing this in regular and normal chem. If you miss manganese and magnesium and then you show me that you just spelled them wrong, I'm not usually that dumb. If you spell magnesium and manganese the same way, I don't give you credit, because kids do that to me all the time. Like, oh, I just spelled it weird. Like, you just got it wrong. Okay. Magnesium. I have issues writing. And manganese. E-S-E. But like, people are scribblers like I am, and they want them both. You'll do fine if you put effort into it, I promise. I've rarely had a kid that tried hard that wasn't able to at least get 40 of them. Okay, that is the end of the first unit or chapter. And I don't have a specific test for chapter 1. It's just wrapped into the test that's still probably a week and a half, 2 weeks away. Because it's all the first 3 chapters. Okay, and I don't know, I haven't used this text, so it may be just 1 and 2. I don't know. It used to be 1 through 4, but then we didn't have a test till almost October. And kids didn't like not having a grade. If you've done the syllabus assignment, though, you all have 100% A. There was a safety thing on there. I deleted it because that was for normal chem, but I had just selected this hour. I deleted that this morning. Okay, time for the lab. I hope that you watch that little video. I don't usually do that, so I might repeat all of it, but hopefully it at least stimulated your brain. If you don't know what video I'm talking about, Grace made the honor roll. Congratulations. Everyone else will get theirs later if they didn't yet. Anyway, hopefully that kind of got you a little bit ready for the lab. So, scatterbrain. Where did I put them? Oh, Tom. There they are. Okay, so you just need 1 per lab partnership here. That might be 2. If it's 2, pass it back. Definitely have dry skin. That's definitely 2. So you can work in groups of up to 3. Geographically based, please, for our contact tracing that will most likely never happen, even if we do get COVID. That's whatever. All right, now you do not need to turn this paper in, but there is this assignment on Canvas. You will do a typed lab report on this, including tables. I'm not like an English teacher. It just needs to look good, and I need to be able to read it. Most AP science kids are decent writers. Way better than online driver's ed students, I'll tell you that right now. I got my all-time low this year on a Grammarly. The girl scored 22 out of 100 on her grammar, which I didn't even know that was an option. But apparently it is. The good thing about that, though, is I know they didn't cheat. The worse the score is, the more likely they wrote it themselves. Okay, so we are going to do a lab. In this container right here is some chalk, citric acid, iron, and sugar. Your job is to figure out how much chalk, citric acid, iron, and sugar there is. How many of you watched the video last night? Okay, so not hardly anyone. Maybe I needed to do a better job. Your job is to separate them and find the percent composition of each one. Now, I won't review percent composition a ton, but you can figure it out based on this example. If we wanted to know the percentage of females in this room, how would we do it, math-wise? Go ahead. And then multiply by 100. So we take the part we want to know divide it by the total, and multiply by 100. And we're going to do that for chalk, citric acid, iron, and sugar. Now, we're going to use and take advantage of the fact that to separate a mixture, we use physical processes. The physical process that you'll use today mainly is called filtration. In this funnel, and all this stuff, except for this, all that stuff is there. When you need a ring stand, it's like kneecap height in that little corner right there. The door's open, you'll see it. All right, so you take your funnel, you take a filter paper, which comes as a circle, you fold it in half twice, and then separate just one side. Now, not the middle, because kids do that all the time. That doesn't help me. I need one side, and that makes a little cone. Now I have a cone that I can put my mixture in and then rinse it with liquids. And then anything that is soluble in that liquid will dissolve and flow through, and you'll collect it in a weigh boat. It's important today that you label your weigh boat. This one has a pencil 0 on the bottom, or O, whatever you want to say. If you want to put your name on it, do it, because you have to keep track of these 3 days from now. All right, so you'll rinse this with a liquid, and anything that dissolved goes through. And then you'll move that, you'll get another weigh boat. And you'll rinse it again with a different liquid. And whatever dissolves in that liquid goes through. Anything that doesn't dissolve in either one of them stays in the paper. Once we've done that, and we think we've washed it enough, you get a third weigh boat. And then you can take this piece of filter paper out, open it up, and then you'll let it dry. And these are going to dry until Friday. They should be dry enough that on Friday we'll come back and weigh them after. Does that sort of make sense? So we're going to filter, but that's only 1, 2, 3 of them, and there's 4 parts. The 4th part isn't super hard to figure out how to remove. Could you maybe, oh, I don't have it up there, think of a way that you could separate one of those 4 that doesn't involve filtration? Don't tell me, tell the people you're going to work with how you would do that. All right. So hopefully you weren't baffled. One of those 4 is magnetic. Now let me show you how to get stuff out that's magnetic without ruining my magnets. So if I put a little bit of this in the weigh boat, and you won't have much, you'll have really just a tiny amount. Whatever. I need to take the magnet under the weigh boat and move it around. You see how I got that out? Yeah. All right, and then I can pour the rest out. Okay, and I can repeat that over and over until I get just my iron. Now, none of it right now is stuck to my magnet. And that's what the goal of this is, that we don't just have a magnet covered in iron. When you've gotten all the iron separated, you can just chuck it, because you're going to weigh the thing after the iron's been removed. The iron's not a very big number, so you get it more accurate if you weigh the mixture after you remove the iron than just measuring the iron itself. I don't know if that makes any sense, but if you're fired up because I just ruined the percentages, you'll be all right. Okay, so, oh, apparently that was not the right way. These are brand new. We're hoping that they look brand new by the end of this lab. They won't in 2 weeks when normal chemistry does a lab like this, but whatever. Okay, now today, like a hair or something. This is the most It's the limiting factor. The slowest part of this whole lab is that everyone that weighs something needs to use this scale. This scale measures to the 10,000th place, so we can get super accurate. So you just kind of have to get in line, just kind of hang out while you're not doing it, and you can set up other pieces. But you need the mass of your filter paper before you put anything on it, because you're going to compare the mass today and the mass Friday, and the difference is the mass of whatever's left. With me? Okay, hold on. Oh. Got it. Okay, now, this is extremely sensitive. It's to the 10,000th. Like if I wave my hand above it, the air pressure is registered. So shut the window, but don't worry if the last number fluctuates. It's the 10,000th of a gram. Like, it's not really that important. Now, absolutely never put your hand on the plate. You can break this very, very easy. So you're going to need the mass of that when it's dry. You're also going to need the mass of these before you put anything on it. All right, so put it in there, shut it, write down, and get out of people's way. Easy enough. Okay, now we know how to separate the iron. The rest, we're going to use water or methanol. So back here, and I already forgot to put these out, I will. I have some hot water on the right. I have some methanol on the left. It's labeled just meth. It is not meth. All right. The first thing you need to do before you really do anything is use a test tube. Put a very small amount, and I'll show you what I mean by a very small amount. So these are scupulas. And I need about that much. Does that look like very much? No, I need this much stuff. I put it in my test tube. I add some water. You would do it with a pipette in the back. And I shake it up and see if the solution goes clear. If it goes clear and there's nothing left on the bottom, then it is soluble. If it looks like that, then it's definitely not soluble. Does that make sense? If it's not soluble, then it stays in the filter paper. If it is, it goes through. So the first thing you need to do is make a data table of the solubility of these liquids, or sorry, of these solids in the two liquids of water and methanol. Now, I said it in the video. I'll try and make sure this part's clear. When you go to do this lab, you must do it in a way that you only separate one thing from all of them at a time. There is a way to screw it up and separate two. And if you do that, then you'll have to come in and on Friday, you'll have to re-separate the two that you separated in the first place. So when you think through this, think logically, all right, I just got rid of the iron. That was one separation, there's three left. The next, you only take one. Now there's two left. The next, you take one. Okay, the way you do it, I pretty much gave you most of what you need. Make sure that you put 5 to 10 pipettes of the liquid through when you're going to filter it out. You can grab, the pipettes are not labeled because you can use the same pipette for water and methanol today. It doesn't really matter if they mix. So just, you can grab more than one and like bring 5 over for all I care and squeeze them in at the same time. 5 might be too many at once because it might go over the top of the filter paper. We should be good. Now, today, please wear safety glasses. They may not look clean. They don't have COVID. They haven't been used since March. This is the first time they've been touched. If you want to wash them, you can. When you're done today, though, we do need to spray them down and wipe them with that rag. I'll put that like right over here or something. And maybe a box. Actually, I'll put the box over there because then I'll put them in the goggle sanitizing thing. and we'll get ready to go. Okay, I think we're ready. Talk with your lab partner. Just for a second, I just need to put the solids out real fast. Okay, real quick, back here. When you go to do your tests, you literally just need a tiny amount. So you get a tiny weigh boat, take your scupula. You can even bring your test tubes here, I don't care, but like a really small amount, and you can go do your tests at your stations. Don't do all your tests right here. Does that make sense? Now, the one that's the sugar and citric acid look exactly the same. Citric acid is in the bigger weigh boat that has a C on it. I'll label them in a second, but you'll probably be back here by then. Chalk is in the middle. It's the powdery looking one. Sugar's on the left. I'll label them, but okay, let's start observing. Some of you, while you observe, send your lab partner to start getting some masses. So not all of you go there at the exact same time. Okay, ready, set, go.